Hello everyone, welcome back to the DSA for Beginner series. In the previous video, we learned about stacks and queues. Today, we are going to learn one of the most important data structures asked in coding interviews, linked list. Many beginners find linked list confusing initially because unlike arrays, linked lists are not stored in contiguous memory. But once you understand the structure, right, so linked list becomes very easy. So by the end of this video, what all you learn, what is a linked list, why do we need it? We'll see the difference between linked list and arrays, how to traverse a linked list, how to insert in a linked list, how to delete from a linked list, and then maybe a couple of example of interview questions. Okay, let's start it. Let's get started. So let's say we have an array of 30, 40. So what if I need to insert an element in between 20 and 30? So what ideally we have to do is we need to shift these two elements to first thing is first we need to have a new array list with the size of 5, and then we need to shift these two elements to the next and then add it into the array. But this is not so easy when it compared to when it comes to a huge array list. So how to overcome this? This is where linked list comes very okay. So this is where linked list helps us to add elements anywhere in the list without performing much of the operation. So how does linked list look like? Maybe let's see. So 10, 20, 70, 9. So this particular section, right? So this will hold address to next node. Basically, if you see in arrays, right? So all these are stored one next to another. But in linked list, this address can be anything. So that is why we have this. Okay. Okay. So this particular part, right? So this is the address to next node. Same goes here. So this will have address to next node. And the first node will be called as head. So this way is called as head. So basically, this is pointing to the first node of the linked list. So how does a structure of a linked list is represented in Java? Let's see that. So we have value to store values, and we have next pointer, so that has the address to next pointer. So this is how a typical linked list looks like. Okay, so let's see some example of how a linked list works. Okay, so in this particular code, right? So here we are initializing head to store the value 10. So this is the head. So head dot next will have 20, and then next to next is 30, then 40. So this kind of coding, right? So this may be easier when we have like 3 or 4 elements. But if we say like we have hundreds of nodes, right? So that is when we can see how to traverse a linked list and then how to insert at the end of the linked list or at the beginning of the linked list. So let's see how we can traverse the linked list. So what we have to do is we have to create a new node. Let's say current pointer. So that points to head. Okay. Then so we keep on traversing the current pointer to next node until current is not equal to none. Okay. So let's see how we can do that. So while current not equal to none, current equal to current. So this way, every time current keeps updating to next element. So first, okay, so what we can do is, uh, so we can have a sys out here. Yes. System dot and current is, yeah. So every time it, the first time it is pointing to 10, that time it prints 10. So 10, then current will be updated to next element, print elements. So that will become 20, then 30, and then 40 until current will be equal to 1. Okay, so we have seen how to traverse a linked list. Let's have a summary of the difference between linked list and arrays. So array and linked list. So first basic thing is memory. So in our array, it is continuous. This is non-continuous. Inserting is O of n time. So here it can become O of n. Deleting is also again O of 1 because we need to. Okay. So inserting is O of n. So, back. So this has a star mark because so if the position is already known, then this will become O of 1, or else this can become O of n as well. Okay. So deletion is same goes here. So if the position of the array element is known, then O of 1 or else O of n. So accessing will become O of 1. But in case of linked list, this dynamic size is difficult to, because let's say if you have created an int of array where you have designed 26 initially, but let's say we have 28 elements, that 2 elements that came later. So at that time, increasing the number of elements in the array will become tedious task. Okay. So now let's see couple of you know uh, techniques which are required in the linked list. How we are going to insert in a linked list. How we are going to delete from a linked list. Okay. So first operation, what we can say is insert a node at beginning. So initial linked list we have 10, 20, 30. So what we're going to do is we're going to give 5. So that has to be inserted at the front of the linked list. Basically, the structure will become like this. 30. How are we going to do this? So basically, we have to create a node, new node, right? Then already we know what this is. This is a head node. So we can make use of that node dot next equal to head. And head will be new node. So basically, we are changing the head of the linked list from here to here. The first one is uh, initially we had 5 and null. Then we pointed to head. So this particular step we are doing here. And then this is changing the head of the node. The new node will become the head of the node. Okay. So again, so next operation. So this was a simple change. So next operation, what we need to know. Second, insert a node at the end of the list. So let's suppose 10, 20, 30. Let's suppose we have one more item, 40. What we need to do is the linked list structure should become 30. Okay. So how are we going to do this? As you remember, sometime back we saw how to traverse a linked list. Basically, we need to make use of this. So we need to traverse the linked list until it is empty. Then you need to insert the node at the end. Okay. The one catch here is we cannot traverse until current is null. We have to stop one behind the current. Basically, head we need to assign it to current while current dot next not equal to null. Current equal to current dot next. Then we just assign the next pointer to so yeah, what we are doing here. So current dot next not equal to null. So what will happen? Current will be pointing here. So until current dot next not equal to null. So it goes to next element, again next element. So here it will stop because the current dot next is null. So it stops here. Then this step will add. Oh, okay. Sorry, my bad. So it stops here. Then as we see, current.next is null here. So this new node will be added. So this is where the current pointer is now. Then this dot next will become 40. Okay, so we saw two operations in our linked list: insert a node at beginning, insert a node at the end of the list. Next, let's see how we can delete a node from a linked list. Okay. Okay, so let's see how we can delete a node from a linked list. So let's suppose we are going to delete this particular element 30. So how are we going to delete it? So here we need to have track of a previous node and then the next node. So that is where we have previous node in the linked list. So what we'll do, we'll initialize this node to a dummy node. And then, so whenever current moves to next pointer, previous is assigned to the current element. So example, initially current is pointing here. The previous is pointing to null. Okay. So the moment we move inside the while loop, right? So previous is pointing here. So previous is assigned here. So previous will become this. And then current moves to next element. So next we'll check if the current value is equal to target. So target is here 30. No, it is not equal. Again, it will go to while loop and then it will start again. So now second iteration, the previous moves here, current moves here. So basically previous will be pointing here, current will be pointing here. Now it checks if the current value is target. Yes, it is correct. So current is equal to target. What we have to do is we need to just remove this connection. How are we going to do this? We just have to assign the next pointer of the previous node to current next node. So that is what we are doing that way. So if by doing that, so here we had 30, so that got deleted. So later, since this has no reference, garbage collection will delete this particular node. Okay, so what we saw today. So we saw linked list. We saw how we insert in a linked list, both front and at the beginning and the end. And we saw how we delete from a linked list. So we also saw how we traverse the linked list. So this linked list topic, right? This is very important in our interview discussions. We'll go through this topic one more time in the next tutorial. We'll see a couple of example and couple of interview questions, like how linked lists are used in the interview questions. Okay, see you in day 6. Happy coding.